Okay, so what problem are we on? 15 and oh, 15 through what? 20? Yeah. Yeah, go ahead, Maddie. I mean, no, sit down. Trying to be rude to you, like, no, go ahead. All right, number 15. So this says we have to go back to number 14. So you guys have the notes from 14 because we did that already, right? So did we not do number 14? Oh, okay. I'm pretty sure we did. That's okay. We can start from scratch. A rectangular storage container with an open top is to have a volume of 10 cubic meters. So I'm going to go back over here and I'm going to draw my rectangular storage container with an open top. What's that? Okay. Thank you. Yeah, so that's different. The length of its base is twice the width. So I'm going to call this x, and I'm going to call this 2x, and I'm going to call that y. Okay? Then it says the volume is 10, so that means 2x squared y equals 10. How do you feel about that? Perfect. All right, then it says let's minimize the surface area of it. And so we know that the surface area is, the lid is made from the same material as the sides. So the bottom is $10 per square meter still. Okay, so that means 2x squared times 10 plus, what are the sides? Nope, that's the bottom. XY would be the front and the back, right? XY would be the front and the back, right? And there's two of those, so it would be 2xy, and that costs $6. Plus, what are the sides? 2xy, right, and then there's two of those, so that means it's 4xy, and that material also costs $6. And then this time, the design department wants to also have a lid on here. So that would be also good. 2x squared, same as the bottom, except this we're going to multiply by 6. Okay, yeah, hot in here, huh? Okay, so we got a bunch of like terms to combine. Oh, okay. Got it. So we got 20x squared right here and 12x squared right there, right? So we got 32x squared. Yes? Then I have 12xy right here and 24xy right there. So that means I have 36xy. So this is the surface area. That's the cost. I mean, I shouldn't say surface area. That's the cost of all the materials. That's what we're trying to minimize. But I got two variables, so I need to solve for one and replace. Well, because I can't take the derivative with two variables at the same time. I knew what you meant. So if I take this and solve it for y, it is going to be 5x to the negative 2. Yeah. Where did I get the what? 2 times 10 is 20. 2 times 6 is 12. 20 plus 12 is 32, right? 2 times 6 is 12. 6 times 4 is 24. 12 and 24 makes 36. Okay, so 32x squared plus 36x times 5x to the negative 2, which simplifies to be 32x squared plus 180x to the negative 1. But did you kind of get that formula? Okay. Right, that's fine. Elena has been doing that too, and that probably makes more sense than what I'm doing because it's H is for height, but what are you going to do? B and H base and height. Okay, whatever works for you. All right, so then I have to take the derivative. What's the derivative of 32x squared plus 180x to the negative 1? Negative 180x to the negative second, and I want to set that equal to 0. Okay? So that means 64x equals 180 over x squared. No. Multiply by x squared. So 64x cubed equals 180. Divide by 64 cube root. You get some crazy weird decimal. That's what x is. Plug that into an equation. Figure out what y is. Take a couple minutes to do that on your own. Let me know when you're done. Or you can just go to the 1/3 power. Uh-huh. Yeah. Yes, you could. Yep. Because root 4 is to the 1/4 and root is to the 1/2 and 1/2 times, yep. You could definitely bring. Uh-huh. Just. Right. And you're pretty advanced, aren't you? Okay, number 16. Show that of all the rectangles with the given area, the one with the smallest perimeter is a square. So I got myself a rectangle. We don't know that it's a square. We're trying to show that it's a square. What do you want to label the sides? X and Y. Show that of all the rectangles with a given area, so let's say x times y is equal to some area A. We want to minimize the perimeter. What's the perimeter of that? 2x plus 2y. Same problem as before. Thanks. Got 2 variables in there. Yeah. Yep. I'm going to go down this road, and then you tell me what you think when we're done. Okay? All right, so I'm going to take this and solve it for x or y. Which one? All right. So that means x is equal to a times y to the negative 1. Does that make sense? Because I divided by y, but then I bring it back up to the top. So that means I can rewrite this as 2ay to the negative 1 plus 2y. All right, now I'm ready to take el derivativo. What's the derivative of 2ay to the negative 1? Good. Negative 2ay to the negative 2. And then the derivative of this is 2. And then I set that equal to 0. So I'm going to rewrite this as 2 equals 2a over y squared. Huh? Well, it was negative and I scooted it over to here. Make it positive. Yeah. That is a y squared. Multiply both sides by y squared, so 2y squared equals 2a. So that means y squared equals a. Yep, so that means that y is equal to the square root of a. And if I take that and plug it back into like here to figure out what x is, then that means x is, bless you, it was contagious, x is the square root of a also. So since the dimensions are the same, that means it has to be a square. Okay? But that's the problem, is you can't prove something by saying that it's true. Not correctly. You can if you're Donald Trump, but you can't if you're a math teacher. Okay. Well, then you can do whatever you want. All right, next one. Show that of all the rectangles with a given perimeter. So now we're switching this around. So we're going to say perimeter still equals 2x plus 2y. And then the area equals x times y. And this, the area thing, is what you're trying to take the derivative of. Okay?
Oh,
Uh-oh.
I did that for
So now I have to take this one and solve it for either x or for y. Which one do you want to do that for? X. So 2x equals 2y minus p. So x equals y minus p over 2. Is that right? It's kind of gross. So that means that the area is equal to x. Wait, we solved for x. Yeah, thanks. Y minus p over 2 times y. So that's y squared minus p over 2y. Okay, yep, take the derivative. Derivative of y squared is, of course, 2y. And then the derivative of minus p over 2y is negative p over 2. Set that equal to 0. So 2y equals p over 2. So y is equal to the perimeter divided by 4. And if you take that and plug it into, where did we solve for x? Oh, so if you take that and plug that into where we solved for x over here, then x would equal p over 4 minus p over 2, which is,
negative p over 2.
I don't know why that came out to be negative. It would be negative p over 4. I don't know why it came out to be negative. It's supposed to just be p over 4. So once again, since the dimensions are the same, that means it's square. Huh? No, it's still, I mean, I was here in the afternoon. It still feels like a long week to me. Yeah, I'm not. Yeah. And I'm going to be gone on Friday. I am going. All right, number 17. Find the point on the line y equals 4x plus 7 that's closest to the origin. So, yeah, we have the distance formula. And that is the square root of x2 minus x1 squared plus y2 minus y1 squared. This isn't going to be that bad, though. Because it's the origin, yeah. So that means that one of the points is 0, 0. So that's going to be like our x1 and our y1. And the other points are going to be, bless you, x and Gesundheit and 4x plus 7. Do you guys understand this, what this has got going on right here? That if you know it's the line y equals 4x plus 7, the x coordinate of any point of it's going to be x, and then to find the y coordinate, you just make it 4x plus 7. I could have written x comma y and then substituted 4x plus 7 in for the y, but, you know. Well, I'm not solving for anything yet. I'm just setting it up so that I can. Okay. All right, so now let's take those and plug that into the distance formula. So this is going to be the square root of x squared plus 4x plus 7 squared. Because this guy right here is 0 and this guy right here is 0. This one right here becomes x, but I do have to square it. And this one right here becomes 4x plus stuff. Okay? Here, did you get all this done? What? Okay. No, we can't cancel because it's being added, not multiplied. And so you can't cancel a square root through. That would be, you're getting yourself into kind of this situation here. Okay? So we can't do that. But I can FOIL this out. 16x to the second plus 56x plus 49. So if I combine my like terms, and I'm going to write it in a derivative-friendly way, I have 17x to the second plus 56x plus 49 to the 1/2. Sadly, no. In fact, none of them are divisible by 7. I know, I'm just kidding. Okay, now if I take the derivative, that is 1/2 times 17x squared plus 56x plus 49 to the negative 1/2 times the derivative of the stuff inside the parentheses, which is 34x plus 56. And I'm going to take that and set it equal to 0. As we have discussed many, many times, the wonderful thing about setting fractions equal to 0 is that you only have to worry about the numerator of the fraction. Doesn't matter what the denominator is. So all of that stuff I don't really care about. So I only have to take 34x plus 56 equals 0. So x equals negative 28 over 17. And then I can take that and plug it back into the original equation to find out what the y-coordinate is. Did anybody do that? 7 over 17? Okay. Did you check your answer? Was it right? Oh, you didn't do it. Did you check your answer? Was it right? We're just assuming? Okay. Because if I'm taking a fraction, if I wrote this out, it would be 34x plus 56 over, because this is a negative square root, 2 times the square root of 17x squared plus 56x plus 49. If I want to set that equal to 0, for a fraction to equal 0, as long as this is 0, it doesn't matter what's on the bottom. 0 divided by anything is just 0. So I can just ignore all of this junk and just focus on the top. Okay? Okay, I definitely don't want to do number 18 unless anybody like really, oh my gosh, but I tried so hard and I couldn't do it and I want to know. Nobody? Okay. Let's see. Go. Not feeling very good about number 19. And not so much, oh, definitely not with the tangent. Okay. Huh? Go. So wrapping up this chapter, anti-derivatives. So if you care like why, it says, for example, a physicist who knows the velocity of a particle might wish to know its position. Remember, we talked about if you take the derivative of position, you get velocity, but you might start out with the velocity and want to know its position. An engineer who can measure the variable rate at which water is leaking from a tank might want to know how much water has leaked from the tank. And then there's some other examples there too. What? We have had a leaking tank and we've figured out, I think, like how long it takes for the tank to get empty or something like that, but we haven't done the total amount of water leaked. Yeah. So what the notation that we're going to use here, you'll notice, is the antiderivative is capital F. Okay? So what we're doing is we're going to start with the function is the original function is just plain old f of x, right? If I take the derivative of that, that's f prime of f. That's the derivative. And then the notation that they will use is capital F of x is the antiderivative. derivative. And of course, the letter will change sometime, but that's usually how that goes. Does that make sense? Didn't I put a, yeah, I put a prime on the derivative. In the definition? Yeah, so what it's saying is the derivative of this equals that. Yeah, okay? And this is just a fun little puzzle for you guys to solve because there aren't any real rules for it. I mean, we can kind of develop some because we're going to figure them out. But to find the antiderivatives, you just like think about it. Yeah, you just think backwards. And that's why I like this. It's kind of just a fun little dealio. So if I start with the sine of x as my function, what is the antiderivative of the sine of x? What could I take the derivative of? What's that? Negative cosine, yeah. Because you know the derivative of cosine is negative sine. So if you want to have the derivative equal sine, then you have to start with negative cosine, okay? Now, there's one little extra piece that we have to throw on here. What's the derivative of negative cosine? Sine, okay? What's the derivative of negative cosine of plus 2? Nope. Sine of x, right? Because the derivative of 2 is 0, okay? What's the derivative of negative cosine x plus 20? Sine of x. What's the derivative of negative cosine x plus 201? Still the sine of x. What's the derivative of negative cosine of x plus 2015? Still just sine, okay? So what we're getting at here is that it doesn't matter what number I add onto that, the derivative will still be sine, right? Because the derivative of a number is always just 0. And so what we're going to do to encompass all of those numbers is we're going to say negative cosine of x plus c. Okay? So that's when it says the most general antiderivative, that's plus c. Okay? Okay, b is no fun. Let's do c. If f of x is equal to x to the negative third, what function could I take the derivative of and get x to the negative third as an answer? You know you're going to start with an x to the negative second because when I take the derivative, I need to subtract 1 from the exponent, right? And so now I'm going the other way, so the antiderivative, I had to add 1 to the exponent. Then I need some junk out here to cancel so that if I put this, right, because then if I put this negative 2 in front, then if there's a negative 1/2 in front there, the negative 2 and the negative 1/2 will cancel each other out. And then negative 2 minus 1 is negative 3, and then I'm going to go plus c. Yeah, okay? So now that we've done one of those with the backwards power rule, let's come up with a general rule for the antiderivative of something being raised to a power. So the first thing that we talked about here was the exponent, instead of being 1 lower when you take the derivative, is going to be 1 higher. So this should be x to the n plus 1. And then in front here, I have to have 1 over what? I need to have 1 over n plus 1. Because when I put this in front, then that has to cancel with that, right? So I need a 1 over that in front. And then when I subtract 1 from the exponent, I would just be left with n, and then that would be, of course, plus c. Okay? Yeah, I mean, basically, you're ready to do the homework now. That's why I kind of left you guys this assignment. I thought you could work on it on your own. So here is, well, it's right here on this table. So here are some common ones. If you, this is just kind of nonsense, but if you start with x to the n, the antiderivative is going to be x to the n plus 1 divided by n plus 1. If you start with cosine, the antiderivative is sine. Start with sine, the antiderivative is negative cosine. We did that to begin with. Antiderivative of secant squared is tangent, and the antiderivative of secant tangent is secant. So there are, I guess, 5 relatively common antiderivatives. Right here, we have upped the ante considerably. Things were super fun and easy there for a little while, and then why would we, keep it simple like that? So before we figure out this antiderivative, we're going to simplify this a little bit. What is 2x to the 5th divided by x? 2x to the 4th. And then what is the square root of x divided by x? Yeah, you subtract the exponents, so you've got x to the 1/2 on top, x to the 1 on the bottom. 1/2 minus 1 is x to the negative 1/2. Okay, so this one it's good for us to simplify first. Notice, I guess, notationally now it says find all functions g. So here they started out saying g prime, so our answer is just going to be g. What is the antiderivative of 4 sine of x? It's negative cosine x, so since it's 4 sine of x, I'm going to go negative 4 cosine x. What is the antiderivative of 2x to the 4th? So I'm going to do the opposite. I'm going to add 1 to the exponent. So I'm going to go 2x to the 5th, okay? Because I'm doing the antiderivative. So instead of when I take the... And then it's going to be over 5. Okay? So that when I put that 5 in front, the 5's cancel, and I'm left with 2x to the 4th. Okay? All right, minus... Then this one I want to also add 1 to the exponent, so that gives me x to the, but I'm at negative 1/2 and I'm adding 1. So that's x to the 1/2. And then I want to divide by 1/2, which is the same as multiplying by 2. So I put a 2 in front right there. Okay? And then again, this one says find all functions. So I have to put a c on the end. Okay? You only do what? Oh, for each one of these things? No. That will sort of come up later. But no, we can just tack on 1 for the whole thing. Okay? All right, so do you guys remember what the assignment was that I asked you to do to try from these? No? Right, so you focused on the other one. Okay. It was 1 through 18, yeah. 279. The code word is refrigerator.